Steam Powered Machine Shop channel. I'm on winter break in Florida, and this episode we're going to be rebuilding the flyball governor. It's a 1910 Pickering governor that was with the engine when we found it, and it goes on the Morris engine that we're rebuilding in the New York shop. And I just want to thank you for all your comments, and over at the Flywheelers show I got to meet quite a few of my viewers, and the reception on the snow engine on the last video, the big 400 horsepower natural gas engine, was very good. In fact, I had one viewer that emailed me and told me that he was pretty sure that his grandfather worked on that engine when it was in the oil fields in Pennsylvania, and there were actually two of them, and the sister engine still exists also, and he thinks he can find a photo and will send it to me of his grandfather's photo when they moved that engine into the oil field in pieces drawn by horses on wagons. So if I ever get that, I'll put it up for you on my G Plus page. Don't forget to check out the G Plus page too, because I put up some photos and things from time to time, and things from other sites that relate to the steam powered shop. So we'll get right to it. This is kind of involved and long, so I wanted you to see how this governor goes together. Thanks a lot. And I brought it down to take it apart, evaluate it, see what it's going to need, and rebuild it. This is just like it came in from the woods. Been sitting outside about 40 years in the woods, and it had weeds growing through it, and I haven't done anything to it other than just soak it up with a little good old liquid wrench, and it started turning. So that's a good sign. I think we're in pretty good shape with this governor. But I was going to tell you a little bit about it. Governors started out, basically all they do is throttle the steam, which controls the volume of steam that goes into the steam chest of the steam engine in order to regulate the speed. And sort of like a throttle on a gas engine does. And it's regulated by this rod that runs up and down through here, and the valve is in this part down here. Now you find a lot of governors in flea markets and stuff where they've just stolen the top off, and you really don't have anything there if you don't have the valve and everything that goes with it down here in the bottom. But there's in order to make this work well, there can't be a lot of effort on this shaft, because this is like a valve, just like a valve you'd screw in or out, except it's got no threads on it. You just pull it in or out. Well, you can't have the steam pressure working against the valve, because then it would be affecting the whole calibration of it. So they made it in here, and you'll see when we get it apart, they made a double valve. It's one valve on top of the other, and the steam goes up through one and down through the other, so that it's balanced and it doesn't take any effort to pull that rod up and down. So what happens here, the original governors came to be known as what they call gravity governors, and they had big heavy balls, either brass or cast iron, that rotated around, and the centrifugal force would pull them out when the engine speeded up, and that would move the rod down and close off the steam. And then, you know, everybody knows from your high school textbooks, when the engine slowed down, the weight of the balls would come down, and the weight of the balls would actually pull the rod up. And this worked fairly well for really slow moving engines, but a guy named Thomas Pickering was actually a young man who was operating an engine in a power plant. This is way back in the 1860s, and he was always plagued with keeping a steady speed, keeping the voltage constant. And so he came up with the idea, and he thought that these gravity governors were way too cumbersome and slow to react. So he thought, instead of using the weight of the balls as they came down to open the valve, that he would use a spring. And he came up with this idea here with like leaf springs on 3 balls, and when this is freed up, the balls fly out and make the top part come down a little bit, which moves the rod. And we went through all this in an earlier video of the shop engine in my shop and how it worked. Now that governor is a very earlier form of a Pickering, and it doesn't have a lot of the features that this one has on it. So this deal with Pickering all began in 1865. That's when he got the patent going, and he decided to build governors, and they were a smash success. They worked really well. And then later in 1885, he came out with a safety deal where the idler that runs on the belt, if the belt breaks, obviously the governor stops and goes wide open, and the engine would run away and stuff gets broke. And so that's not good. So he invented this little deal with it. He had a very heavy pulley here on this that would hold the governor belt tight. And if the belt came off or broke, this dropped down, and there's a spring-loaded device that's on the other side. I'll show it to you. Right here. It's a better way to show it. This spring-loaded device with this ratchet. I don't know if this will move, it's still stuck, but we'll demonstrate that later. It was used to hold the rod up against, this rod is in 2 pieces, up against the rod. Well, when this drops down, this little pawl unhooks, the ratchet unlocks and lets the rod drop all the way to the bottom. There's a little shoulder on the valve so it can't drop all the way down, and it would shut the steam off and save the day. So that was a very good improvement. Then you also, it said in his ads, that in his advertisements, that by cranking this thing up and putting more pressure than you really need to on the spring, you could affect the speed of the engine. And I've tried that on my other one and different ones, and boy, I'll tell you, it doesn't affect it much, if any. So later, he came up with the idea of an adjustment. Now, in order to adjust the speed of a steam engine, when you got one of these set up on it, there's really 3 ways to do it. You can speed up the governor or slow down the governor as in relation to the crankshaft by changing the size of the pulley either here or down on the crankshaft. So it runs the governor a little slower, so the engine would have to run faster in order for the governor to get into its regulating range. That's one way. And all of these governors have a speed stamped on them. Now this one says 525 RPMs, shaft revolutions. And I've seen 450. I think my governor on my shop engine is 450. All different RPMs. And I imagine there's different numbers of these leaves, different weight balls, all different kinds of ways of doing that. But the other way is to lengthen or shorten this rod that runs down through here so the valve is held in a different position. And in order to do that, you gotta, like on my other governor, that's the only way you can adjust it, is to take this acorn nut off the top, pull that rod out, up a little ways, and there's like a little jam, 2 nuts that are jammed together there, and you can run them up or down, which makes the rod be held down a little more or up a little more. That's the other way you can do it. Or in 1907, Pickering came up with this thing called a range adjustment, and everybody calls it the ball ranger. But what it is the rod is actually in 2 parts, and this wheel right here will adjust the speed, and it's really effective. You can slow the engine way down. Well, if you push it all the way in, if you run it all the way in, you can slow the engine way down to a crawl, or you can open it up, and the further you turn this little wheel, the faster the engine will go up to a certain point. Well, this was really cool because, like a thrashing rig or something, they had to run the engine at exactly the right speed in order to get the thrashing machine to work right and everything. So that was a real great feature. And the way they did this is they had a bunch of ball bearings. I think there's 7 or 8 of them in there. They're about 1/4 inch in diameter, and when this screws in, it pushes more of those balls down in there, and the balls get between the 2 rods and make them longer, makes the rod longer or shorter. And you'll see how that works when we get this apart. And then the last patent he had, one of the last patents, was in 1910 on what he called a self-locking auto stop. And it's got a cam right here, and then there's another piece on this pawl that you can't really see. So when this thing drops and it drops the pin down, it actually locks it down as far as it can go by the weight of this. So it's a more positive improvement. That's what the collar looks like. You also oil it. You shoot a little oil down in there, and this cup holds a little oil that runs down into this bottom bearing. Or this bottom bearing runs down into there. Okay, next thing, you get the pulley off. Just give it a tap or two and see, and I'm not going to force it. Get this out of the way. Okay, they come off pretty easy. Okay, now I'll get over on this side so you can see. Make sure we get this. Come on. There it is. There's the double valve, you can see. Bottom and the top. And it's on a little bit of a swivel, so it's sort of self-aligning. These are the two ears that it drops down onto the seat, and it won't let it go all the way any further. Spiders, all kinds of things in there. There's two brass rings that are pressed in for valve seats. They're just straight like bushings. So the steam comes in here, goes out there into the engine. Okay, there's a tapered pin right here holding this piece here on the shaft, and the whole trick there is to figure out which end of the tapered pin is the smallest. Sometimes it's kind of hard to tell, and you just kind of got to guess. And I'm pretty sure this is the way this one goes. Oh, it's loose. See, there isn't much taper to it, but you drill a hole just a little bit smaller than the small size of the pin, and then there's a whole set of tapered reamers. They're numbered, that match the pins, and you run the tapered reamer in there and then drive the pin in the right way around so that it tightens up. And that's the great granddaddy of roll pins. Spring pins. That's what almost all machinery was held together with before roll pins were invented, and they work pretty good. Sometimes you get one that is a chronic problem that wants to get loose, but usually they don't. Okay, we'll give this one a go. Right out. It's on the floor somewhere. And we got one in here. You can see it. Yeah. Talk about locking out. There's the two pins. And one on the floor. There's just enough rust underneath this spring to make this come out hard. Got it soaked up and freed up, and it comes right out. How about that? This is a little collar that runs in there and just sort of follows, makes this shaft follow what the rod does. Okay. Next thing, we got to get this junk out here. Ah, yeah. There it is. Well, that was fairly painless. Okay, now we'll work on freeing this up. Okay, now the ball ranger is right here and it's pinned to this lower shaft, and I think it'll come right out the way things have been going here. I may be wrong. this should come right out. Yeah, and that's the whole valve assembly. And these angles are cut on each of these ports so that as it opens, it does it gradually. The port is uncovered from this corner over to that corner, and it affects the characteristics of the governor, the sensitivity of it, how much this has to move in order to achieve the opening. So there's quite a little bit of cut and tried work involved in designing this governor, or any governor. Thousands and thousands of hours of making different kinds of valves and trying them in different engines and seeing what the results were. Okay, I got this Ranger cleaned up and oiled up a little bit. They're a little tough to get apart because they got a lot of things pinned in them, and the pins have to be installed just right or they bind, and this one is working really good. This is the upper pin, the upper rod that goes up through the ball and spring assembly, and there's a little pin that's just pressed in part way to make a feather key here for this to run in so that this won't turn, this won't rotate. And if I screw this in and out, you can see it working, and it works really freely. I put a little oil on it, and you can see what it does. It just lengthens this pin, this rod. So that'll be fine like it is. Patented, you bet your life it is. And there's the patent number right on it. May 21, 1907. Pickering Ball Ranger. Free at last. Alright, the plan is to replace these springs, which are all rusted out. And the way they're anchored in here is there are notches in this disc here, and the springs fit in the notches, and there's screws that go in there to hold it. And then there's a brass ring that's pressed over the whole thing, and then these cavities are filled with babbitt. That's the way they did it. So first thing that has to happen is these brass rings have to get pressed off. a little crooked. I don't want to distort it. So there it goes. One down, one to go. Okay, the last thing to take apart is the balls to get the springs out. They're actually screwed together, hopefully. Get them loose. And there's the springs. Well, there's the whole afternoon's job. Disassembled. Some of the stuff is cleaned up. Ready to get to work on it. Okay, this is just a cosmetic cut. A couple of thousands off here just to pretty it up a little bit. Get the rust off it. We're back to work on the governor today. I had a chance to clean up the parts on the wire wheel and look at things a little better. And I cleaned up this idler. It was pretty ugly. It was rough cast, kind of a curved surface here. So I machined it just because I wanted to. It's faced off the end and put a 6-degree angle here with the compound, and it looks a little bit better, and it runs pretty true. And cleaned up the pulley a little bit, polished it up, made a little cosmetic cut there. Okay, next order of business is the springs. This is one of the old springs, as you can see daylight through it. And it mics out at right at about 12 thousandths, 12 and a half maybe. And I had some stock here, but it's too thick. It's 20, and that would change the calibration on the governor. So what would we do without McMaster car? I ordered this stuff yesterday morning and shipped it out of the Georgia warehouse. Just going to cut one of these loose. Quick. You can measure it. See what we got. My neighbor in his 66 Chevelle. 12 thousandths, 12 and a half. It's the same stuff, all right. 1 inch wide. Yep. Okay, so now we got to cut 9 of these things. 3 on each ball to length, and hopefully you can drill the holes. I don't know how hard this stuff is. We'll find out. This is actually 1095 spring steel, and it comes at C48 Rockwell. The steel material that I wanted to get was what they called general purpose 1074. It's a little softer, but it didn't come in the thickness that I wanted, and I wanted to keep the thickness right at 12. They had like 15 and 20 and 10. So believe it or not, you can actually drill this with a high-speed steel drill, but you got to sharpen the drill about every third pass, and it works much better one piece at a time. So you kind of learn as you go along. There was some hand fitting I had to do with a Dremel on these holes to get them all to be the same, because the screw is a pretty nice fit in there, and they also, the tops and the bottoms fit in here pretty nice. So I think I got it now. Now these ball assemblies, if you look at them, 2 of them are offset, these wire bales are offset off the center and one is in the middle, so that you can put one this way, one that way, and one that way, and they'll all be at the same height. So we'll start out with the bottom one. And we'll put the center one in. Fit into a notch so it can't turn. And this one will go on the top. No. Yeah. Let's see, what do we got here? Oh, this one goes this way. Okay, that's the bottom, that's the center, this is the top. Okay. I'll tighten them up later. Okay. Ready for Babbitt. I just put taped a piece of cardboard across the bottom, keep it from leaking out. I'm heating the ladle back up over here. Okay, we're going to test fit the whole thing together. I mic'd the valve and the valve seats, and they're very close tolerance. There's only about 1,000th clearance, and I thought they had more clearance than that, but I've never seen one that wasn't worn out, so evidently that's enough. Actually, you got brass here, and brass, the rings are brass, so they expand at roughly the same rate, so it might not require that much. This is a taper hole on top, and the ball ranger drops on there. Tapered pin holds it. I said originally there was no gasket here. Well, there was. It was a real thin paper gasket. So I'm going to make a gasket for it eventually when I get some other things. This 4-bolt pattern here allows you to put this anywhere you want it, so that your steam inlet comes where you want it on the engine. Just put one bolt. I made a new shaft for this because the old one was all beat up and worn on the ends, and it's going to require 3 holes drilled and reamed with a taper reamer for these tapered pins. I didn't have the right reamer. I ordered it twice. The first one was wrong. The second one got sent to my New York address, so rather than hold this video up, I'm going to just assemble it together loosely so you can see how it goes, and I'll drill and tap these holes, or drill and ream these holes later. Okay, there's a shim washer on there. Next thing will be this shaft, and it's the same deal. You got a tapered hole here, so you got to get the big end of the hole facing out, and the big end of this hole, I marked it, so that goes there. Takes the long pin. Okay, the thrust this way is taken by the end of the shaft, which goes through just the right amount and rubs against the machine flat on the casting. So that's captured. The turret goes on. We gotta put the little collar in there. The whole thing drops down. You can check the gear backlash. Right now we don't have any, so put another washer in there. Okay, now you can see there's just a little backlash, so we're pretty good on that. And these gears look pretty nice. So now you can see how the springs work. Next thing is the top part of the shaft, the rod. There's one thrust washer on the bottom and one, I think, on the top. Or 2 on the bottom, 1 on the top. That's the way it was when I took it out. That goes in. I'm going to move this around so you can see it better. That top drops. Okay. There's a pin that just sticks into the hole a little ways that fits into a keyway in this top shaft. So we're engaged there. Tighten that up just a little bit for the time being. And then this top nut has a thrust surface. Okay, then this shaft goes in with the Sawyer's lever. This yoke engages in the ball ranger. There's two slots on either side. Goes in like a shift fork on a clutch. Goes in. Then the spring, then the ratchet. Oop. It's under this pawl. And then that little cam goes on the end. I'm going to drive this pin down in here while I'm thinking. Okay. And then when this spring is reeled up a couple of notches on the ratchet, it keeps this shaft pulled up in the wide open position. And the ball ranger in here with this knob on the back side, I'll show you in a minute, is adjusted so that the length of the rod is right. And then when the engine starts up and the balls come out, it begins to push the rod down and shut the steam down. So that's basically how it works. This little shaft that I made because it was worn, and I drilled a hole for the pin. Okay. And this has got the cam which holds the ratchet mechanism locked down if the emergency shutoff unhooks the ratchet here and unwinds, lets the spring unwind. And then this is the arm for the idler that goes in here, and you got a whole lot of different notches you can put it in, and we won't have any idea where it's supposed to go until it gets mounted on the engine. So I'll just put the washer on the end and the cotter pin in. Okay, the idler goes on there with a cotter pin, and the pulley goes on. It's got a lot of room for adjustment for a lot of different applications. And there's the governor. So there's the Pickering governor, 100 years old, ready to report for duty. You'll see it again. We're going to put this on the Morris engine that we're rebuilding up in New York, and hope to test run it this summer. And that's about it for this video. Thanks a lot for watching. Thanks for all your comments might want to check my G Plus page once in a while for some news or some photos that I put up. And we'll see you again.